Bergson and the holographic theory of mind. Continuing, this is going to be on Bergson's forgotten question and why it's the critical question for the theory of consciousness. And ultimately, we'll talk a little bit about the implications for GhatGPT. This was a driving question of matter and memory. Is experience stored in the brain? Bergson, in his 1913 intro to Matter and Memory, said this: anyone who approaches without preconceived ideas and on the firm ground of facts the classical problem of the relations of soul and body will soon see this as centering on the subject of memory. For soul and body, we can equally substitute mind and matter. For the, quote, subject of memory, unquote, he means, is experience stored in the brain? I am most curious if anyone has seen this question openly, squarely addressed in the academic literature on the hard problem of consciousness. Let me know. Again, I emphasize on the hard problem of consciousness. I have never seen it. Yes, one might make an exception for Sheldrake, who disputes that experience is stored in the brain, but he never actually truly places this in the context of the hard problem. The question, in my opinion, currently does not exist. It is totally forgotten. So also for soul and body, we can equally substitute the hard problem of consciousness, as we've been noting. The total lack of any address of Bergson's question in the hard problem literature, this shows how deep is the theoretical misunderstanding of the problem. That is the hard problem. So, we're going to see why this question is critical. Going to look at the simple experience. Good old coffee stirring. Perceiving oneself stirring coffee in his cup on the kitchen table using a spoon. Now note, this is an event of conscious perception with all its qualia. The specific swirling of the liquid, the browns of the coffee, the cream color of the mixing cream, the form of the cup, the feel of the stirring spoon and its periodic motion. This is the hard problem. What we'll see. Any attempt to account for this ongoing, dynamically changing, conscious perception of the coffee stirring via any model involving storing this experience in the brain, for example, in short-term memory areas or immediate-term memory areas, is utterly doomed to failure. That is, we're on the very ground floor of why the question, is experience stored in the brain, is indeed critical to the problem of consciousness. Again, I repeat, this is the hard problem. How do we perceive the coffee stirring with all its qualia, a conscious experience? This is the experience that we must account for. Coffee stirring on the kitchen table, with its ongoing via some concept of storing its structure, as it is ongoing in the brain. Now, we're going to review a few things we've seen in other video segments, but I'm just putting it all together here for everyone's quick view in this context of this problem of the hard problem, so we can see it out, how it all slams together. So the seemingly inescapable propensity of current memory theory is to break this event into features that will be stored in various cortical areas. So various features stored in various cortical areas, feature 1, 2, 3, 4. And it might be the rim, the liquid, the handle, the table. One can go on and on, except this is et cetera, et cetera. This is the starting assumptions of the Moskovich et al. Model. This is 2016 Annual Review of Psychology, Episodic Memory and Beyond, Hippocampus, and Neocortex and Transformation. And all those names, Moskovich, Winokur, Nadel, are big names in memory theory. So assumption number 1 was the perception of an event, that's objects or scenes, are comprised of feature clusters. 2, there's a persistence of the feature clusters during perception via neural activity. Then encoding the event, or a fraction of the event thereof, because ultimately they only encode fractions of the event, the hippocampus becomes an index to multiple aspects of the event stored in multiple areas of the cortex. So somewhere around there, we have the hippocampal complex, HPC, and there's an index in there to all those features that are stored in the cortex. So we'd have a hippocampal index pointing to all the various features. Then retrieving the event, the hippocampal complex, HPC index, is engaged, retrieving and reassembling the multiple cortically stored aspects of the event. Now, one can see there's no principled way that this will become more apparent, to identify and list these features of assumption 1. It's fairly arbitrary. It's up to the imagination of the theorist. You can keep right on going, as you can see, starting listing the aspects of this event, which you're calling features. Things to do today. Well, maybe that's an aspect. Those pictures on the cup, the blue of the cup, etc., etc. Could go on forever. But for the sake of analysis in this event-as features context, we'll start here with something apparently easy, the cup. Now we're going to make it a whimsical cubical cup with a handle, for surely a cube has features no one can take issue with: edges, vertices, sides. Hummel and Biederman, 1992, in contemplating the connectionist model for object recognition, how to recognize the cup as a cup, label it as a cup, already ran across the problem. You can take an object, our cube there with a cone on top, and break it into all kinds of features, the various vertices that they're listing down there. So break it into these features and store them in various locations. But here's the question: how is Humpty Dumpty, so to speak, put back together again as a cube? Because those features can go back in all kinds of configurations that don't necessarily look like a cube. One has to know what the original object looked like to reassemble the separately stored features properly. For example, the vertices and edges in the right spatial arrangement, like a cube. And reassembling is assumption 4. And over the 4-dimensional time-extended course of the event, it means parsing and reassembling state with its feature cluster after state with its feature cluster after state over and over in real time. Hummer and Biederman proposed decomposing the object into geons, elementary 3D objects like cones, bricks, etc., to help keep the features together. But this model has its own problems, to include essentially being an attempt to provide the brain with a nice picture on the cover of the puzzle box, so to speak, that helps put the puzzle together. So somewhere in the brain would have to be the bricks and the cones, etc., and somehow the brain knows how to use that picture. But the situation is worse. We need only to start rotating our cubical cup. Now the use of features hits the correspondence problem. So imagine each state of a full rotation, say one state every 1 degree thereof, as a cartoon frame. Thus the rotation becomes a series, 360 in number, of cartoon frames to cover the full rotation. As the cube rotates frame by frame, each of the features must be tracked, and the identity of each must be preserved. So we'll start with that corner, feature A, and as the cube rotates, we have to make sure we're tracking that corner feature A there, across the frames. So feature A in frame 1, feature A in frame 2, etc. Feature A identified again in frame 3. This problem was eventually declared intractable by perception theorists. This fact alone might have stopped Moskovich et al. And their assumptions in their tracks. But of course it didn't. Theorists of form perception moved to velocity flows, as we've seen in many vids, as key in the perception of form. The same optical flows that J.J. Gibson had earlier declared as critical to perception. The flow field there on the right, an array or a matrix of velocity vectors, a gradient of velocity vectors, where each vector, the velocity thereof, is proportional to 1 over the distance squared from the eye of the observer. These fields are ubiquitous. And here we've got a little rotating cube that is composed of the flow fields. Again, a flow field as the cube turns towards us, etc. contracting flow field as it turns away, etc. But in this they encounter the aperture problem. So here we have a line gradient moving under an aperture. So the line gradient moves under that circle there, but the ends are now obscured. So only the downward motion is seen. So the eye, being an aperture, occludes the actual ends of the lines moving at some velocity. This occlusion causes the computation of the line's direction and velocity to be uncertain. So this led them to the position that within all perception, there is an intrinsic uncertainty, that all perceptions must be viewed as probabilistic. So a percept is always being an optimal specification based on the best information possible. So we'll come back to this, but consider what I termed the Gibsonian cube. So I noted that up there. As the side rotates towards us, it presents an expanding flow field. As it rotates away, it presents a contracting flow field, while the top is a radial flow field. So what are the features in this cube? The edges, the vertices. Well, they're now merely sharp discontinuities at the junctures of these flows. That is, the features, quote unquote, are extremely dynamic, defined only over these flows. It is these flows that must be stored, quote unquote. The flows cannot be stored as a series of states and as snapshots, each state holding a snapshot of the cube with all its features. So we'll pretend, again, we've got the snapshots of that cube rotating. The features are invariants defined of the flows. They don't exist actually in one of these snapshots. If the flows are disrupted, as we've seen, strange things happen. Take a rotating cube made of rigid wire edges. The cube has a symmetry period of 4, being carried into itself every 90-degree rotation, or 4 times per full revolution, hence symmetry period of 4. If strobed in phase, at an integral multiple of the symmetry period, 4, 8, 12 times per revolution, the cube is seen as a rigid rotating cube. If strobed out of phase, say 5, 9, 13 times per full revolution, the rigid features of the cube disappear. It becomes a plastically deforming, non-rigid object, and definitely not a rotating cube. So note first, each strobe is a sample, a snapshot, and the vertices, edges, if indeed static, should exist in this snapshot, just as we've got there, but they do not. Secondly, the brain appears to be expecting a certain constraint to be fulfilled, a la spatial symmetry, as in a regular cube, very spatially symmetric, implies temporal symmetry, that is, regular pulses, as it were, as the cube rotates. If not met, the optimal specification is to a plastically deforming, wobbly, non-rigid object. The brain is specifying, but still optimally now, deformed flows, a non-rigid, plastically deforming, not a cube. So recur back to our starting model, that of identifying features within the incoming perceptual input, storing them within some short-term memory area in the cortex, then reassembling these in real time as the perception of the coffee cup, which we set rotating. It seems clear that the coherence of it all is dissolving. Problems. The concept implies that we could track the features from stored state to stored state, and some mechanism reassembles the event. That is, the intractable correspondence problem is not a problem at all. Wrong. It implies that there are plenty of hidden puzzle box covers sitting around to aid the brain in putting the features of the cup back together properly in the first place. It ignores that these features seem to exist only over flows. But how are the flows stored, except if not as a series of states? And we see the series of states doesn't work, given the strobe rotating cube. In fact, in bringing this up, we realize that the entire reassembling concept, sets of features assembled and presented in state after state, is surreptitiously assuming a fundamental continuity. In essence, it is assuming consciousness itself. For how is the series of reassembled states seen as a continuity, as we perceive it there, as a flow, as the continuous rotation of the cup, or in the picture there, or the continuous circling of the spoon? How is it that is our experience per this model, not just a state, then another state, then another state, then another state, then another state. That is never more than one state, one instant of the rotation of the cube. In essence, it is equally assuming memory, the Moscovitch model, which provides continuity beneath the states, so that we see the cube rotating. In fact, we're getting a glimpse now of the concept that memory and consciousness, as Bergson saw, are one and the same problem. The above is just a different statement of something noted by Michael Turvey, the ecological psychologist. If state or snapshot after instantaneous state of the coffee stirring must be stored in a static space in the brain, like a series of snapshots laid out on the desktop, a vast static structure, how does one reintroduce the motion? As Turvey pointed out, via some internal scanner. Then he argued, how does the scanner register the motion? An infinite regress begins, scanner after internal scanner after internal scanner. This leads to a worse problem, namely the very structure of this coffee stirring event that is also being ignored. Again, that structure, the invariant structure, velocity flow fields, like a radial flow field on the surface, an adiabatic ratio, the energy of oscillation to frequency of oscillation, carried in a haptic flow field in the arm, an inertial tensor, etc., acoustical invariants. These invariants, like the edges and, quote, vertices, are defined only over time, over the flowing transformation of the external field, of which the coffee stirring is but a subset. These, for example, the adiabatic ratio, the inertial tensor, do not exist in an instant. So if we are disassembling the event into features, quote unquote, in the real time, and storing these in a very short-term memory, and of course reassembling these in real time as required for the needed, usually assumed internal or mental representation of the stirring event, we must wonder how is this structure of invariance with its requisite flows being stored? Well, this is never addressed. All coherence with respect to disassembling or parsing into static features, quote unquote, storing these and reassembling them again over and over and over is again dissolving here. The adiabatic invariant may be dubbed a feature, quote unquote, but it is not extractable and storable as a static element. And this ratio of energy of oscillation over the frequency of oscillation, not extractable as a static element. And again, even if one could make sense of placing this feature successively in a series of states, where is the continuity coming from? The time glue, so to speak. But Kugler and Turvey saw as a haptic flow field in the motion of that spoon and arm, with this adiabatic invariance incorporated in this haptic flow field itself, part of the continuous motion of the stirring spoon. A better view of the problems can come from looking at an alternative. What if, we ask, the brain is simply reflecting this dynamically changing structure of the coffee stirring or the cube rotating symmetrically, a symmetric reflection in near simultaneity with the event, allowing for the slight time delay needed for transmission of the information in the optic array to the eyes and through the neural structure. So you're going to have a time delay gap there always. It's going to be an important gap. This is to say, there is no attempt happening at storage in this model. We're simply resonating, shall we say, or reflecting symmetrically the external structure. So no attempt at storage in some yet to be unequivocally found short-term storage areas. And this is simply because, as one can see in contemplating the nature of these dynamically changing invariant structures with their flows, there can be no such attempt. There simply are no logical points in time at which to be storing anything. This was Gibson's position. He envisioned the brain resonating to the external event, something elucidated more in his description of perceptual activity, wherein he envisages the brain continuously adjusting, tuning to the invariance, seeking the highest fidelity of reception relative to the dynamic information. Symmetrically, then, the invariants specifying the event are equally defined over this resonant attuning activity of the brain. Thus, while Gibson is noted for arguing that the information in the external world, the invariance is specific to or specifies the external environment. For example, our texture density gradient there on the right, where the cups are. But again, these are ubiquitous. Here's a texture density gradient on the left with flowers. So the texture density gradient is considered specific to a surface stretching in the distance. The vertical separation S of the circles or texture elements there on the right is S equals or proportional to 1 over d squared. There's another texture density gradient on the left there. So it is true by symmetry then to also say that the dynamic state of the brain is specific to the external event, the surface stretching in the distance. So Raja in 2019, in this article in Minds and Machines, emphasized this symmetry recently. Notice this, a theory of resonance toward an ecological cognitive architecture. So he noted that this fills in more fully what he's going to describe here, the nature of Gibson's resonance description of the brain. That is, where the brain is simply resonating to the coffee stirring and not storing things like features. In the yellow there, he's going to flesh out the central metaphor according to which the animal perceives its environment by resonating to information and energy patterns. Raja uses one of many examples, the well-studied, that is by ecological psychology, invariance laws employed by a baseball outfitter to guide his action systems to intercept and catch a fly ball. In this case, the fielder constantly moves in order to cancel the lateral motion and vertical acceleration of the fly ball to his own movement, so as to maintain a homogeneous expansion of the ball as a radial flow field, the ball's a radial flow field, in his visual field. Thus, the invariance specific to the baseball's arc through the air and simultaneously to the action systems involved in the outfielders catching the ball must be reflected in the neural processes of the brain. Raja says, resonance is what is going on inside the organism, especially in the CNS, the central nervous system, with regard to what is going on at the ecological scale. Let's repeat that. Resonance is what is going on inside the organism of the brain with regard to what is going on at the ecological scale. In other words, you're symmetrically reflecting the structure of the external event with its invariance laws within the brain. Raja employed a description of the central nervous system and the invariance of the environmental event based in dynamic systems theory with all its attractors, etc. Given the right parameters, this demonstrates the symmetric reflection of the invariance. So basically what you've got is each side of our gap there, the event, that is the event on one side, certain things in the CNS on the other, is characterized by variables describing each as a dynamic system with its attractor. So I've got an attractor in the brain. This is an old picture I used for a talk in 2001 in Vienna, actually. So the rotating cube is also described as a dynamic system. Always, of course, mapping onto itself every 90-degree rotation. And you demonstrate that the two systems reflect each other, that they change in tandem. Such a view of things removes the clunky approach of storing features of the coffee stirring or of the flying baseball, whatever such features would be in this case, because remember, they're always arbitrary, instant by instant, storing them instant by instant, ridden as this is with logical dilemmas, as we've seen. It leaves the memory dilemma. It leaves the memory dilemma. In the symmetry schema, where the brain is simply resonating to and with the structure of the event, I nevertheless noted it would be only a near simultaneous symmetry. There's a time gap. Why? Because the event is still in the past. It is a limited extent in time of what was a past transformation of the external field. facing the coffee cup. We are perceiving the position of the spoon nearing the 3 o'clock position as it is and was moving from the 6 o'clock position. But this present perception from 6 to 3, shall we say, there's already more optical information arriving at the retina as the spoon is happily on its way to the 12 o'clock position. So there's always this gap. We are seeing the motion of the spoon, some time extent of its movement from, say, the 6 o'clock to the 3 o'clock position in a circle. We are back to the memory underlying this, which we know has great difficulty being a series of stored states. Even the resonance view then would seem to share something akin to the second assumption of Moscovitch et al., namely this one. There is persistence of the feature clusters during perception via neural activity. John Taylor, used a similar concept in a Journal of Consciousness Studies article to quote, "The features of an object bound by various mechanisms to activity in working memory thereby provide the content of consciousness of the associated object," namely the cup, actually the stirring itself. In these neural activity loops, neural activity relaxes to a temporally stable state, therefore providing the extended temporal duration of activity necessary for consciousness. There's much one could take issue with in that, but let's just ask this. What is the time extent of this neural activity? Just long enough to specify the spoon in motion from 6 to 3 and then from 3 to 12, allowing there is actually a sliding window actually kind of happening from 6 to 12. Whatever the theorist needs, see, it's entirely arbitrary. By what principle is this neural activity limited then to a certain extent of time? Why is the brain not a vastly extended 4D object per this conception with no need for storing anything? For a vastly extended 4D object is exactly what the brain is per the space-time block of special relativity. And in both Taylor's and Moscovich's all statement, there is no principle by which you could limit the four-dimensional extent of the brain. So, as we'll see, it's a complete contradiction to the metaphysics they're actually working in. The fact is, the temporal extended duration of activity necessary for consciousness is merely a convenient device to slip in the continuity needed for perception, that it is a surreptitious way to slip in an explanation for consciousness, simultaneously to slip in an explanation for memory underlying, or the memory underlying consciousness, for inescapably consciousness implies memory. At this point, I think we've seen pretty clearly why, taken in the basic elementary context of the perception, that is experience of stirring a cup of coffee, the question as to whether experience is stored in the brain is critical. This is equally to say that the question is critical, or a critical component of the hard problem. We're looking at the hard problem, the origin of the image of the coffee being stirred with all its qualia. So we have come to the solution that we've been looking at throughout this series, just via this different direction. That is the profound problem of memory underlying conscious perception of that coffee being stirred, where we're seeing memory and consciousness are basically part and parcel of the same problem. Without memory, there is no consciousness. Beneath this, all we know is what I've discussed as the classic metaphysic, that abstract space of points and positions, an infinitely divisible space. The motion of the cup or our spoon in our coffee stirring is a series of points, and between each pair of points, another line of points, ad infinitum. So, as we noted, this is an absurdity, for motion becomes a set of immobilities and an infinite regress. Each point of the cup's trajectory corresponds to an instant of time, equivocally a static, instantaneous cube of all of space. So, an infinitely divisible 4D abstract continuum, the basis of all mathematics and AI, the classic metaphysic. This metaphysic is a source of seeking how experience is stored in the brain. For each instant, Each present cube falls into the past, into non-existence as the present arrives. The brain is considered matter, and matter is always, quote, present, unquote. So we must store the past instant in the present brain to preserve it. Each instant has a time extent, logically, of a mathematical point when the infinite division is, quote unquote, done. This is the logical extent of neural continuity. So pleading that there's neural continuity when its extent can only be that of a mathematical point in time is ignoring your own metaphysics, the very reason why you're seeking to store memory in the brain in the first place. Bergson, we saw, introduced the temporal metaphysic. Motion is indivisible. The transformation of the universal field is indivisible. In other words, we throw the infinite divisibility away. And this transformation is like a melody, each note considered an instant, interpenetrating, permeating the next, each reflective of the entire preceding series. This allows specification of the past, as we've discussed. The coffee event, surface swirling, spoon circling, is a transformation of and within the external field. Note the coffee cup as a system is only arbitrarily demarcated from the entire field, the entire transforming field. And this is a transformation that is not to be characterized by instants, each present instant successively falling into the past. The transformation participates in the primary memory attributable to this indivisible transformation, or each moment, so to speak, permeates the next. The brain, symmetrically resonating to the invariance defined over this transformation, albeit slightly delayed, is enabled to be specific to or specifying a certain extent of this past transformation of the field, the swirling coffee, and some past portion of this stirring spoon's path of motion. By the way, just as an FYI, this article is going to appear in the flagship journal of Gibson, the Ecological Psychology, at some point this year, soon I think. It shows that Gibson's concept of time is equally Bergson's. That is, Gibson works within the temporal metaphysic, and his entire vision of the brain, the invariance, etc., works within this temporal metaphysic and can't be understood without it. Gibson's resonance framework, construed within the temporal metaphysic where it belongs, gives us a route to avoid storing elements or features instant by instant in the brain to achieve something as basic as the perception of stirring coffee, and allows the necessary specification of a past extent of the transformations of the environmental field. The resonating brain is still just neural chemical flows. However, there is no image of the coffee cup. That attractor does not look like a coffee cup. Nothing looking like the coffee cup within the brain doesn't exist. So, in essence, you've got not only a time gap, but the famous phenomenal gap, because within the brain, there's nothing looking like the phenomenal experience of stirring coffee. Moskovich, as they are only describing neural processes, embody this dilemma in their model, where they propose that all the static features are bound, quote, together with the feeling, the phenomenology of the experience in the hippocampal complex, HPC. In other words, they are binding what the coffee cup and stirring actually looks like with its swirling coffee surface, etc. That is the phenomenology to neural activity. So the phenomenology, which just seems to be hanging around, waiting to be bound to the neural activity. I mean, in other words, this is absurd. Obviously not a solution, but it's their attempt to acknowledge that their model doesn't come close to explaining the image of the external world, the coffee cup and stirring spoon. And for this, we've seen the solution, namely Bergson's matter and memory model, where the field in which all this is embedded is a holographic field. It's transforming indivisibly. The brain becomes a reconstructive wave passing through this field. In other words, the field is the whole hologram, which the brain as a reconstructive wave is passing through and specific to a source within this field. That is the coffee cup and stirring spoon, though as a past transformation of the field. So the external field is holographic. Gibson's resonance becomes part of the brain's action as a reconstructive wave, passing through the holographic field specific to a source within the field by this process. An image, the coffee cup and stirring spoon. So, is experience stored in the brain? Not even a question to current theorists. Yet the question is so intrinsically bound to the simplest exemplar of the hard problem, that is how we have the experience of coffee stirring with all its qualia. Well, it's sad. I suggest dropping some of the self-assurance, go back to a tremendous intellect that visited this problem long before it was ever coined, that is the hard problem, and before it was simultaneously misstated by Chalmers. And take a look at Bergson. Postscript. GhatGPT, sort of bouncing off a discussion, brief discussion of it. I've seen plenty of other discussions, but this is interesting by Jordan Peterson. This video is entitled The Dark Side of AI, a warning from Jordan Peterson, the scary truth about GhatGPT. Yes, we're faced with the AI army. So GhatGPT is an AI language program based in statistical analysis, massive statistical analysis of a massive body of human speech, basically internet, wiki, this massive pile of data they've got of human speech, extracting patterns, and then using predictive processing based on this understanding of patterns. What, if I say the man stirred the coffee cup with the, it's got a predictive algorithm that will say spoon. Spoon's the most likely thing to fill in the blank. The man stirred the coffee with a blank. So it can do some pretty incredible things. Jordan, for example, says he gave it this task: write me an essay on the 13th rule. I'm bouncing off his book there, the 12 Rules for Life. The 13th rule, written in a style that combines the King James Bible with the Tao Te Ching. He said it did it in 3 seconds, a 4-page long essay, and he considered it great, indistinguishable from something he himself would write. And he regales us with several other anecdotes about what GhatGPT can do. I mean, basically, we're looking at high school students never having to write a thing again. Every essay they'll write can come from GhatGPT. Of course, this is the absolute death of creativity of the human mind. But anyhow, we'll go on. For Jordan Peterson, the next step is extracting patterns from the real concrete world. They'll set GhatGPT on this. Extracting patterns from the real concrete world and pairing this with its linguistic knowledge, making it super powerful. That is, this is the implication. Think of it clearly. GhatGPT is going to understand coffee stirring. All the invariant structure over time. In other words, all the problems noted in this vid are going to be of no account. Got to let this sink in. You will not have this. A brain resonated in symmetry to the external event and its invariant structure over an indivisible flow of time. The resonance also being and part of comprising a reconstructive wave passing through the holographic field. Not going to have that, but this. A Turing machine with this discrete state, quote, time, unquote, which is no time. It's the classic metaphysic time, attempting to affect by storage in its memory, state by state by state by state, understanding of, that is the experience of the coffee stirring. In other words, there is yet the impassable gaps, the time gap and the phenomenology gap, which if you understand what we just said, those two gaps are really one and the same gap, because time is, the indivisible melodic flow of time is embedded in part and parcel of the phenomenology in the first place. So despite even more impressive AI things, nothing is going to hide this fact. And you'll have people like Hofstadter and Sanders, again, will still find on deep analysis of AI language translations, now based on the new GhatGPT, like from French to English, that the machine fails miserably when it comes to having to translate based on analogies that exist in one language but not in another, or one culture not in another. And this is just the beginning. One could do a video, in fact, on the, and one should, on the list of things one should look for where these weaknesses of the GhatGPT come out, precisely because it's a completely wrong model. It's the classic metaphysics Turing machine model, and it cannot do anything but kludge what reality is in terms of actually perceiving the coffee story and experiencing it. Lastly, just to remind, this is all part of AI's hitherto unsolvable common sense knowledge problem. The time problem, the memory problem, the phenomenological problem, that is the origin of the external world problem, all part of the common sense knowledge problem, intrinsic. Jordan's apprehension and enthusiasm are the results of, quote, training GhatGPT in the concrete world is simply a reflection of his unawareness of the problems. Yes, visual image statistics, looking at enough coffee stirrings, can associate spoon and stirring coffee, I'm quite sure. Even throw in some action. Maybe the machine has an arm and stirs coffee. This is not going to be the equivalent of the experience of the invariant structure, where the liquid's resistance demands a force applied by something like a spoon to move it. In other words, spoon and liquid are not arbitrary associates. They're intrinsically involved in the concrete forces of the invariant structure of the event. We're not associating them, but this is what the machine will have to do. And this structure exists only over the indivisible flow of time and the memory, as we've seen, intrinsic to this flow. All, in principle, not registerable by the AI machine, by the Turing machine, in its classic metaphysical time. So next we'll see. Till then, signing off.